Hello students, this is a video on the topic tests available for Quant on Bodhee Prep. The idea of these topic tests is once you've gone through a topic, you want to check whether you're able to do those questions in the exam, you take the topic test. With every test, there is a video which gives you the solutions and a brief analysis of what would have been a good attempt in that test. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for which is in the description of the video. Make sure you download the app and make the most of these tests. This video is on the topic probability. This is the third test that we're discussing. Overall, I think this test was probably moderate level of difficulty, and about 6 to 7 questions in around 20 minutes would be a 95 plus percentile attempt. Now, if you look at the questions read, when a missile is fired from a ship, the probability that it is intercepted is 1 by 3. So if it is intercepted, probability 1 by 3. So not intercepted, probability will be 2 by 3. Intercepted means it is stopped from going to the target. Not intercepted means it is going towards the target. And the probability that the missile hits the target given that it is not intercepted. Now, if it is intercepted, what is the probability of hitting? If it has been intercepted, it can never hit the target. If it is not intercepted, in that case, the probability of hitting the target is 3 by 4. Therefore, probability of a missile hitting the target will be 1 by 3 into 0. Either this happens or this happens. It is intercepted or not intercepted. Intercepted cannot hit, not intercepted 3 by 4. So the probability becomes 0 plus 1 by 2. So the probability of a missile hitting a target after launch is 1 by 2. If 3 missiles are fired independently from the ship, then the probability that all 3 hit the target will be the first hits the target, probability 1 by 2, the second hits the target, probability 1 by 2, the third hits the target, probability 1 by 2. So overall probability of all 3 hitting the target would be 1 by 8. Option 3 becomes my answer. That's an easy question. All we have to do is find the probability and then independent events. So multiply about 1.5 minutes to solve the question. The coefficients ABC of the quadratic equation ax square plus bx plus c is 0 are obtained by throwing a dice 3 times. The probability that the equation is equal roots. Now, if I look at the total outcomes, we'll have A can have any one of the 6 values 1, 2, 3, 4, 5, 6. B can have any one of the 6 values. C can have any one of the 6 values. So total number of combinations of values for ABC will be 6 into 6 into 6, which is 216. What is the favorable cases? Favorable cases will be when the equation has equal roots. Equal roots means discriminant is equal to 0, which means b square minus 4ac is equal to 0. If b is 1, 1 square minus 4 cannot be 0. B has to be even because 4ac is even, 0 is even. If b is 2, 2 square 4, a and c can be 1 and 1. So this is one case. If b is 2 square 3, 4, 9. If b is 4, 4 square is 16. We could have 4, a could be 1, c could be 4. With b4, a could be 4, c could be 1. Or with b4, we could have a and c as 2 and 2. 16, 4, 1, 4 into 1 into 4, 4 into 4 into 1, 4 into 2 into 2. If b is 6, we will have 36. For 36, we need 4 into 9. The only possibility is 3 and 3. So for these 5 cases where B, A, C are respectively 211, 414, 441, 422, and 633, we will have discriminant 0 and therefore exactly 1 root. And therefore number of favorable cases is 5. Total cases is 216 and therefore the probability becomes 5 upon 216. Again, I think a moderate level of difficulty question, basic concept in that sense, about 2 minutes to solve. In a group of 400 people, 160 smokers, non-vegetarians, 100 smokers, vegetarians, okay. Smoker, non-smoker, vegetarian, non-vegetarian. 160 smoker, non-vegetarian, 100 smoker, vegetarian, remaining 140 non-smoker, vegetarian. Their chance of getting a particular chest disorder are 35%. The first group was smoker, this is 35% chances. Smoker, vegetarian is 20%. Non-smoker, vegetarian is 10%. a person is chosen from the group and is found to be suffering from the chest disorder, probability is the selected person is a smoker non-vegetarian. Now, how many smoker non-vegetarians are expected to have chest disorder? 35% of 160, which is 35 upon 100 into 160. 5. 7 5 is 35, 5 2 is 10, 8. 56. How many smoker vegetarians are expected to have a chest disorder? 20% of 100, which is 20. How many non-smoker vegetarians are expected to have the disorder? 10% of 140, that is 14. So total number of people expected to have a chest disorder is 56 plus 20 plus 14, 60, 70, 90. Out of these, 56 are smoker non-vegetarians. So the probability of smoker non-vegetarian, the person being smoker non-vegetarian is 56 favorable cases upon 90 total number of cases, divided by 2, 28 by 45. Again, option 3 becomes the answer. I'd say moderate level of difficulty question. The calculation is not very high, and we've come across these questions while practicing as well. Let A be a set of all 4-digit numbers whose exactly one digit is 7. Then the probability that a randomly chosen element of A leaves remainder 2 and divided by 5. So let us first look at the total number of cases. There are 4 possibilities. 7 could be the first digit, then 3 blanks. 7 could be the second digit, then 2 blanks. This is a number that is fixed. 4-digit number. 7 could be the third place number. The rest are blanks. 7 could be the last digit. Now, to fill these numbers, I will not use 7 again. So here there are 9 into 9 into 9 possibilities. Anything from 0 to 9 except 7 can be used. We cannot have 0 here. So 8 options here. 9 into 9 options here. Similarly, 8 options here. 9 into 9 options here. Similarly, 8 options here. 9 into 9 options here. This happens, or this happens, or this happens, or this happens. The total number becomes 9 and 9 is common in all of them. 8 plus 8 plus 8, 24 plus 9, 33. Total number of cases with exactly 4-digit number, the number is 33 into 9 into 9. What are the favorable cases? Favorable cases we need, they should be divisible by 2 and should have 7. So one possibility is it ends in 2. So when we divide by 5, remainder will be 2. So this is fixed in its place. 7 is fixed in the first place, or 7 is fixed in the second place, or 7 is fixed in the third place, because the number has to have a 7. So number of possibilities here is 9 into 9. Here it is 8 into 9. Here it is 8 into 9. Numbers ending in 2 and having exactly 7 will be 9 into 9 into 8 into 9 into 8 into 9. That becomes 9 common. 8 plus 8, 16 plus 9, 25 into 9. The second possibility is the number ends in 7. The number of numbers here will be 8 into 9 into 9. This will also leave a remainder of 5. So, total favorable number of cases becomes 25 into 9 plus 8 into 9 plus 8 into 9 into 9. Which will be 25 into 9 plus 72 into 9. Taking 9 common, 25, 72. 97 into 9. This is the favorable number of cases. This is the total number of cases. Therefore, required probability is simply 97 into 9 upon 33 into 9 into 9. 9 and 9 cancel. 97 is prime. So 97 upon 270 to 297. Option 3. Again, I think in terms of level of difficulty, I would say conceptually moderate, because the concepts used are pretty simple. The calculation might take time. So 2.5 to 3 minutes to 2.5 to 3 minutes to solve. A 7-digit number is formed using the digits 3, 3, 1, 2, 3, 4, 5, 6, 7. 3, 3, 4, 4, 4, 5, 5. Probability that number so formed is divisible by 2. Total number of cases 7-digit number. So we have to arrange 7 digits, out of which 2 are same, 3 are same, 5 are same. So total arrangements will be 7 factorial upon 2 factorial, 3 factorial, 2 factorial. Favorable cases, 1, 2, 3. The last digit has to be 4 so that it is divisible by 2. So before this 4, I have 2 3s, 2 4s, and 2 5s to arrange. This can be done in total 6 factorial, out of which 3s are same, 4s are same, 5s are same. This becomes a total number of cases. This becomes a favorable number of cases. Therefore, probability simply is 6 factorial by 2 factorial, 2 factorial, 2 factorial upon 7 factorial by 2 factorial, 3 factorial, 2 factorial. 6 factorial cancel, 7 is remaining, 2 2 cancel, 2 2 cancel, 2 factorial, 3 remains, 3 goes to the top, or the reciprocal of 7 by 3, 3 by 7 becomes the required probability, option 3. Again, in terms of level of difficulty, conceptually it's a moderate. Basic arrangements thing is used. Also here the calculations are not very high, so about 2 minutes to solve. A fair coin is tossed a fixed number of times. Let the number of times be n. The probability of getting 7 heads is equal to the probability of getting 9 heads. Probability of getting 7 heads out of n tries is given by NC7 1 by 2 raised to power 7 for heads into binomial event 1 by 2 into raised to power n by, because it is a unbiased coin, we'll get NC7 1 by 7 raised to power n. Probability of getting 9 heads out of n will be NC9 into 1 by 2 raised to power n. These two are equal. Therefore, NC7 is equal to NC9. This happens when n is equal to 7 plus 9, that is 16. Basic concept from combination. We have to find the probability of getting exactly 2 heads. So, out of 16 tries, if I want to get 2 heads, the probability will be 16C2 1 by 2 raised to power 16. NCR into probability of success raised to power R into probability of failure raised to power n minus R. Here probability of success and failure is same 1 by 2, so 1 by 2 raised to power n. This becomes 16 into 15 by 2 into 1 by 2 raised to power 16. This is 8, 2 cube, cancel out. So 15 upon 2 raised to power 13 will be the required probability. That will be 2 cube, cancels out here. Option 1 becomes the answer. I think direct application of the formula, so easy, about a minute and a half to solve. Let A denote the event that a 6-digit integer is formed by 0, 1, 2, 3, 4, 5, 6. So these are 7 digits. We have to form a 6-digit number without repetition. The number has to be divisible by 3. Probability of event A is equal to. Now the total number of numbers that can be formed without repetition, 6-digit, in this case will be 1, 2, 3, 4, 5, 6. 1 to 6, any digit can come here. Suppose 2 is used, 0, 1, 3, 4, 5, 6. Any one of the 6 digits can come here. Suppose 1 is used, 5 remaining, then 4 remaining, then 3 remaining, then 2 remaining. These will be the total number of numbers that can be formed. 6-digit numbers using 0, 1, 2, 3, 4, 5, 6 without repetition. Now we have to see favorable cases, that is divisible by 3. The sum of these digits is 2, 3, 6, 10, 21. This is divisible by 3. So we will remove the numbers that are divisible by 3 so that the sum remains divisible by 3. So the digits that I can choose is, we remove 6 first. 0, 1, 2, 3, 4, 5. 6 digits, sum is divisible by 3. We remove 3 next. 0, 1, 2, 4, 5, 6. Sum is 18, divisible by 3. Then we remove 0, 1, 2, 3, 4, 5, 6. These 3 are favorable cases. The number of numbers that can be formed here are 0 cannot come in the first place. 5 options here. Then 5 into 4 into 3 into 2 into 1. Similarly here 1, 2, 3, 4, 5, 6. 0 cannot come in the first place. 5 into 5 into 4 into 3 into 2 into 1. Here there is no such problem. 6 into 5 into 4 into 3 into 2 into 1. 1, 2, 3, 4, 5, 6. This happens or this happens or this happens. If we add, see 5, 4, 3, 2, 1 is common throughout. 6, 5, 5 are different. So if we add, we'll say 5 plus 5, 10. 16 into 5 into 4 into 3 into 2 into 1 becomes a favorable number of cases. Therefore, probability will be 16 into 5 into 4 into 3 into 2 into 1 favorable cases upon 6 into 6 into 5 into 4 into 3 into 2 total number of cases. 5, 4, 3, 2 cancels out. We are left with 16 by 36. Divide by 4, we'll get 4 by 9. Option 2 is the answer. I think moderate level of difficulty in terms of concept, because it is forming 6-digit numbers and we know the constraint for 0. Calculation might take time, so about 2 to 2.5 minutes to solve. A pack of cards has one card missing. 2 cards are drawn randomly and are found to be spades. The probability that missing card is not a spade. Now, if I have to draw out a spade, 2 cases are possible. One is spade is missing, and then we draw out a spade or draw 2 spades. We could draw a spade in this manner, or spade is not missing. Spade is not missing, and we draw 2 spades. Either this or that. This is the total number of ways or in which we can draw out 2 spades. Now, in how many ways can a spade be missing? Spade, there are 13 cards out of a total of 52. So the missing card could be chosen 13 into 52 ways. Once this has been done, we have to draw 2 spades. Now spades remaining is 12 out of 51 cards. One spade is drawn out. Then there are 11 spades left out of 50 cards. If spade is not missing, then one of the 39 cards is missing. Once this other card is missing, we have to draw 2 spades, which can be done in 13 upon 51 into 12 upon 50 ways. 13 spades out of 51 cards. One is taken out, 12 remaining out of 50 cards. We have to find out the probability of this happening overall. Spade is not missing and we draw 2 cards. Therefore, the required probability becomes favorable case upon total number of cases. We have to solve this. Now we see denominator in both the cases 52, 51, 50, that gets cancelled out. All of the terms have 13. All of the terms have 12. So what is remaining here is 39. What is remaining here is 11 plus 39, which is 50, and therefore the required probability simply becomes 39 by 50. Option 3. I said this is a difficult question because technically conditional probability is involved, and if you're writing the entire formula, can get a little daunting, especially if you're not very comfortable with it. So difficult question, about 2.5 to 3 minutes to solve. Let a computer program generate only digits 0 and 1s to form a string of binary numbers with probability of occurrence of 0 at even places be half. 0 at even places is half, therefore 1 at even place will be half. Probability of 0 at odd place is 1 by 3. So 1 at odd place will be 2 by 3 because it is generating binary number 0 or 1. The probability that 1 0 is followed by 0 1, 0 1 is followed by 1 0, followed by 1 0 is 1 0 is followed by 1 0 is followed by 1 0 is followed by 0 1. This is what we want to do. Now see, there are 2 cases possible. We do not know where this string has been generated. Now, one possibility is that this is an odd number. The other possibility is this is an even number in the sense that even place. So what happens is this: the case 1 is we have odd, even, 1 at odd. 1 at odd is 2 by 3. 0 at even is 1 by 2. 0 at odd is 1 by 3. 1 at even is 1 by 2. So this becomes 2 cancel 1 by 18. Case 2 could be that this place is not odd but even. So even odd is what we have. Even 1. Even 1 is 1 at even is half. 0 odd. 0 odd is 1 by 3. 0 odd is 1 by 3. 0 even. 0 even is 1 by 2. 1 odd. 1 odd is 2 by 3. So this also becomes 1 by 18. Either this will be an odd place or even place, so this happens or this happens. Therefore, overall probability will be 1 by 18 plus 1 by 18, which is 1 by 9. Option 4 becomes an answer. Again, in terms of maybe concept, the question is not difficult. So attempt time and the numbers are also easy. But I think it's a tricky question because there is a very good chance of us taking only one case, assuming that the number is starting from 1 itself and taking only the first case. So therefore, a very high chance of this question going wrong. If cards are drawn at random from a pack of 52 cards without replacement, then the probability of a particular card drawn is nth at the nth order. Suppose I want to draw ace of clubs as the fifth card or third card. Let us keep the number simple. We are giving n a value of 3. We are giving n a value of 3. Now the first card. This can be drawn in 51 out of 52 ways. It should not be the ace of clubs. Right? It could be any one of the 51 card out of the 50 total cards. This is taken away without replacement. The second card then can be drawn in 50 upon 51 ways because 51 cards are remaining. One card we've already taken out. The second card should not be ace of club. The third card then, it has to be the ace of clubs, only one way of doing it. And there are 50 cards available now. How many ways can this be done? 50, 50, 50 and 50 and cancel. The probability will be 1 by 52. Now, if I put the value of n as 3 here, this will not give me the right answer, this will not give me the right answer, this will not give me the right answer. The answer is 1 by 52. Again, putting values, I think, is an easy way of doing it, about 1.5 minutes to solve. So, if you look at the overall test, moderate level, 20 minutes, 7 questions. For me, my 7 questions will be 1, 2, 3, 5, 6, 7, 10, which are these. Again, attempting this because easy numbers and I think seems doable. Have looked at similar questions earlier. This I think I've done this question earlier. It's also definitely attempting. This also I think was an easy question. Not very difficult numbers to deal with. Here I will not count this as a definite attempt because the calculation was a little too much and therefore there are good chances of a mistake happening. This one I think was easy. Would have attempted it. This also I think was easy as long as you understand that one property of binomial where NCR is equal to NCN minus R. Apart from that, there were not too many calculation. Uh, this probably could have been attempted because conceptually not very difficult, though I think calculation might be a little difficult, but yeah. I'm not counting this as a definitely doable question because we tend to go into writing the formula for conditional probability, which makes this question difficult. This also, I think, was a tricky question because there is this, feeling that one is the first number, and therefore missing out on the case is very easy here. Not counting this as a definite question. This again, I would have attempted because just give the value of n 3 or 4 and make the case. So out of 1, 2, 3, 5, 6, 7, 10, I'll get my 6 to 7 questions net correct for a 95%.